August 1st, 1956, President Dwight D. Eisenhower stepped into history by signing the Federal Aid Highway Act, unleashing a project unlike anything the United States had ever attempted. The Interstate Highway System was conceived not merely as a means to connect cities, but as a demonstration of national strength, mobility, and resilience during the height of the Cold War. At a time when fears of Soviet invasion and nuclear attack loomed over the American public, Eisenhower envisioned a network of roads capable of moving troops, equipment, and civilians quickly across the continent. Yet at the time, many engineers and planners doubted that such a massive undertaking was feasible. The proposed standards seemed extreme: thicker concrete slabs, deeper roadbeds, precise rebar placement, and extended curing times were all requirements that contractors found both daunting and expensive. Critics warned that the costs would be astronomical, that federal inspectors would be unable to enforce quality across thousands of miles, and that the roads themselves might fail before their time. Eisenhower, however, was adamant. He demanded permanence, durability, and redundancy. The roads were to be overbuilt intentionally, designed to withstand stresses far beyond normal highway use. This wasn't a vision driven by vanity or ambition alone, it was rooted in experience. During World War II, Eisenhower had observed the German autobahns, witnessing firsthand how well-constructed highways could move armies and sustain critical logistics. He understood that a strong transportation network was not merely a convenience, it was a strategic imperative. The Interstate Highway System would connect the nation in ways no previous project had imagined. Thousands of miles of roads stretching coast to coast, designed to support military convoys, emergency evacuations, and the daily rhythms of civilian life. Every inch of these roads was to be engineered with the mindset of permanence. It was an audacious vision, one that required cooperation between federal and state governments, contractors, engineers, and construction crews. And from the very beginning, the message was clear. These roads were being built not to last a decade or two, but for generations. Federal engineers laid down requirements that seemed almost unimaginable at the time. Concrete slabs were to be thick, commonly a foot or more, and reinforced with steel rebar grids meticulously spaced and tied to exacting tolerances. Every slab was treated like a structural masterpiece, designed not only to carry the weight of daily commuter traffic, but also the heaviest military convoys imaginable. Roadbeds were excavated to deep subgrade layers, filled with compacted gravel, sand, and other stabilizing materials, ensuring that the foundation could support millions of tons of traffic over decades. These weren't ordinary dirt roads simply paved over. They were engineered platforms, resting on precisely prepared earth designed to resist settlement, erosion, and frost heave. Slopes were carefully graded, shoulders were reinforced to prevent crumbling at the edges, and drainage systems were engineered to channel water away from the road, protecting the concrete from the rutting, cracking, and erosion that had plagued earlier highways and local roads across the country. Every section of highway underwent meticulous calculations. Engineers factored in maximum vehicle loads, the repeated stresses of freezing and thawing cycles, seasonal soil movement, and the slow, inevitable settlement of the earth beneath. No detail was too small. Expansion joints were designed to accommodate temperature swings across hundreds of miles, preventing cracks from forming as concrete expanded in the summer sun and contracted in winter frost. Curbs, medians, and overpasses were included in the calculations, each with tolerances measured in fractions of an inch, ensuring that every structural element interacted harmoniously with the rest of the roadway. Contractors were expected to follow construction schedules with almost military precision, and federal inspectors monitored every step. Every pour of concrete was timed to ensure proper hydration and curing. Long curing periods were mandated so that the concrete could achieve its maximum strength before opening to traffic. In many modern projects, deadlines dictated by political calendars or budget limitations override engineering prudence, but the first-generation interstate highways prioritized performance over speed. Every day saved by rushing construction was considered a liability decades into the future, a risk that could result in early cracking, rutting, or catastrophic failure under heavy loads. Contractors initially pushed back. They argued that the specifications were excessive, that the materials were costly, and that extended curing schedules would delay delivery and inflate budgets. Some doubted crews could maintain the precision required across vast distances, with multiple teams working simultaneously in remote stretches of terrain. There were fears that weather, logistical challenges, and human error would compromise the work. But the government insisted. Substandard work was not tolerated. Sections of highway that failed inspection had to be rebuilt regardless of expense or inconvenience. The philosophy was simple and uncompromising. Compromise on quality, and the road might crumble within a few years. Demand perfection, and the highway could endure for generations. The scale of these standards also demanded innovation. Contractors developed new machinery and pouring techniques to handle large slabs of concrete with consistent density. Steel rebar grids had to be fabricated and placed with unprecedented precision, with inspectors verifying every connection and overlap. Survey crews ensured that roadbeds were leveled to exact tolerances, often within fractions of an inch over hundreds of feet. Even environmental factors were taken into account. Drainage culverts were positioned to prevent water accumulation during storms. Embankments were reinforced to resist erosion, and bridges were integrated seamlessly with the road network to accommodate both vehicular and military transport. In short, these roads were overbuilt by design. Every element reflected a deliberate strategy to achieve permanence. While modern infrastructure often focuses on speed and cost efficiency, the first-generation interstates were constructed with the mindset of generations, designed to outlast decades of wear and tear, traffic, and weather. Every mile, every slab, every inch of steel rebar embodied a philosophy. Build it right the first time, and it will last far longer than anyone could have imagined. Construction crews approached each mile of the new interstate like it was a monumental engineering achievement, not merely a strip of asphalt or concrete. Thick concrete slabs, often 12 inches or more, were poured in carefully measured sections, each reinforced with steel rebar placed with painstaking precision. These grids weren't random. They were calculated to distribute weight evenly across the entire roadway, preventing cracks from forming under the repeated stress of millions of vehicles. Trucks, buses, military convoys, and even tanks would travel these roads, and every slab was engineered to withstand decades of relentless use. Expansion joints were installed at calculated intervals to accommodate the natural expansion and contraction of concrete as temperatures fluctuated across seasons. Shoulders were not afterthoughts. They were reinforced with compacted layers of gravel, sand, and other stabilizing materials designed to prevent erosion and maintain the integrity of the main roadway for generations. Every element, down to the slope of the pavement and the angle of drainage ditches, reflected a consideration for decades of wear and tear. Subgrade preparation was equally meticulous and far more demanding than modern road construction often allows. Crews excavated several feet beneath the surface, removing soft soils and unstable layers that could settle unevenly over time. These were replaced with compacted layers of gravel, sand, and crushed stone, each carefully leveled to provide a foundation capable of supporting massive and repeated loads. Even a small lapse in compaction could lead to settlement, cracking, or rutting, a problem that modern highways frequently suffer from when corners are cut to save time or money. Drainage was engineered as an integral part of the system rather than an afterthought. Culverts, underdrains, and side channels were precisely positioned to ensure water never lingered beneath or alongside the roadway, preventing freeze-thaw cycles from undermining the concrete slabs. These measures, standard in the 1950s, are rarely applied to the same degree in contemporary highway projects, which often prioritize speed and budget over longevity. Every slab poured underwent rigorous testing before construction could proceed. Crews measured density, moisture content, and curing progress, ensuring that the concrete would reach maximum strength before opening to traffic. Steel rebar grids were inspected repeatedly. Every connection had to be secure, every overlap had to fall within strict tolerances, and every bend had to be aligned perfectly. Even slight deviations could compromise the load-bearing performance of the pavement decades into the future. Supervisors and federal inspectors walked every section, checking levels, alignment, and integrity, with tools that might seem painstakingly old-fashioned today, but were essential for the precision these highways demanded. The process was slow, deliberate, and often grueling. Crews labored in all weather conditions, from sweltering summer heat to freezing winter cold, because the engineers and federal standards allowed no shortcuts. Workers had to wait for concrete to cure fully before driving machinery over it, sometimes leaving freshly poured slabs untouched for weeks, a practice almost unheard of in modern construction schedules. Yet the results were roads that could bear the heaviest loads, survive harsh weather, and remain reliable decades after the original construction teams had moved on. These highways were more than transportation corridors. They were engineering statements. They reflected a philosophy that embraced meticulous preparation, scientific testing, and a long-term perspective rarely matched in modern infrastructure. Each mile, each slab, each steel grid carried the foresight of engineers who understood that roads were not just for the next season or the next election cycle. They were for generations. The Cold War added an entirely new dimension to the construction of America's interstate highways. These roads were not just civilian arteries connecting cities. They were strategic lifelines for national defense. Engineers designed every mile with the understanding that in the event of war or emergency, these highways might need to move tanks, missile transporters, heavy artillery, and convoys of supply vehicles at unprecedented speeds. Ordinary traffic was never the only benchmark. The first-generation interstates had to withstand extreme loads, repeated stress, and the wear of vehicles far heavier than any family car. To validate their designs, engineers conducted exhaustive tests on newly completed sections. Heavy military vehicles were driven repeatedly over the roadways, far beyond the loads they would normally see from civilian traffic. Entire convoys of trucks, jeeps, and armored personnel carriers rolled across the slabs, bridges, and overpasses, generating vibrations, deflection, and stress patterns that could be carefully measured and analyzed. Bridges were built with redundancy in mind, often including extra steel reinforcement and thicker concrete than strictly necessary, so that even under maximum military stress, failure remained highly unlikely. These test sections became proving grounds for the entire interstate system. Engineers monitored every inch of the roadway. Sensors and measuring devices were used to track deflection in the concrete slabs, vibration frequencies transmitted through the subgrade, and any signs of micro-cracking in steel reinforcement. Settlement of the subgrade beneath the roadway was measured with painstaking precision, with adjustments made when readings indicated uneven compaction or shifting soil. The data collected during these trials was used to refine subsequent construction practices. Curing times were optimized, slab thicknesses adjusted, and subgrade preparation techniques improved based on real-world performance under heavy loads. It wasn't enough for a road simply to survive the occasional truckload. These highways were expected to endure years of traffic at maximum capacity, including the heaviest military convoys imagined at the time. Tanks weighing dozens of tons, loaded missile transporters, and large convoys of supply vehicles became tools of scientific validation. Each pass of these vehicles provided crucial information on the resilience of concrete and steel, confirming, or occasionally prompting adjustments to, engineers' calculations. The rigor of the testing reflected a philosophy that valued long-term performance over short-term expedience. Concrete slabs were observed for the tiniest cracks, rebar was monitored for stress and potential deformation, and subgrade settlement was recorded down to fractions of an inch. Engineers sought not only to meet the specifications of the design documents, but to exceed them, understanding that the highways might face conditions far beyond anything predicted. Every observation, every measurement, every test informed the construction of the next section, creating a feedback loop that continuously improved durability and reliability. Viewed through a modern lens, it becomes clear just how extraordinary this level of scrutiny was. Civilian roads today rarely undergo this kind of rigorous stress testing, and modern budgets and schedules often preclude repeated inspections or iterative improvements. The first-generation interstates, by contrast, were built with a kind of obsessive attention to durability born of both ambition and necessity. They were designed not simply to transport people and goods efficiently, but to provide a network that could withstand the weight of national security itself. In short, these highways were engineered to survive the extraordinary. While contemporary roads often buckle under the pressures of ordinary traffic, the 1950s interstates were stress-tested against the unimaginable, and they passed, mile after mile, section after section. It was this combination of precision construction and relentless testing that created a system capable of enduring decades of wear, from daily commuters to the occasional tank convoy, proving that foresight and rigorous engineering could produce roads built to last generations. As the decades passed, the durability of the 1950s interstate highways became impossible to ignore. Roads built with thick, carefully poured concrete, precise steel rebar grids, and meticulously compacted subgrades carried millions of vehicles over generations without ever requiring full-scale reconstruction. The design philosophy of the era, prioritizing long-term performance over short-term cost savings, was proving its worth in real time. Consider a section of I-80 in Pennsylvania, completed in 1958. More than 50 years later, it remained fully operational, handling traffic volumes that had grown exponentially since its opening. Trucks, buses, and passenger vehicles rolled over the concrete slabs day after day, yet the road showed minimal signs of the wear and tear that typically plagued later highways. Slabs stayed aligned, rebar remained strong, and drainage systems effectively channeled water away, preventing erosion or cracking. Engineers inspecting the road decades after construction could still see the fingerprints of careful planning and rigorous standards embedded in the very foundation of the roadway. By contrast, highways constructed in the 1970s and 1980s began to show serious problems far sooner. Cracks, rutting, and potholes emerged within a decade of completion. Pavements that were designed with thinner concrete, less stringent rebar placement, and faster construction schedules failed under traffic volumes that the first-generation interstates had easily withstood. The difference was not subtle. It was stark and unmistakable. Sections of interstate that had been overbuilt, tested rigorously, and monitored continuously were still carrying traffic safely, while modern highways required frequent patching, resurfacing, and expensive repairs. Traffic studies from the 1960s through the 1990s demonstrated just how resilient the original roads were. Even as the average daily vehicle count doubled or tripled, the slabs rarely shifted, and the steel reinforcement maintained its integrity. Drainage systems, installed with meticulous care during the original construction, continued to protect the subgrade from water infiltration, preventing the freeze-thaw damage that often crippled later roads. Maintenance crews reported that much of the work required on these original interstates was routine cleaning, repainting, and occasional resurfacing, rather than the extensive reconstruction that modern highways demanded within a fraction of the time. The performance milestones of the 1950s interstates became case studies for civil engineers across the country. They were living proofs that rigorous construction standards, thicker concrete, full-depth compaction, meticulous rebar placement, and long curing times paid dividends over the long term. While newer highways were repaired, overlaid, or partially rebuilt multiple times within 20 years, the original roads continued to serve their purpose with minimal intervention. Even in areas of high traffic congestion or harsh climates, these first-generation highways endured, maintaining their structural integrity where later roads failed. This longevity was no accident. It was the result of a philosophy of over-engineering, careful inspection, and uncompromising standards. Every inch of pavement reflected decades of research, testing, and foresight. The first-generation interstate highways weren't just built to meet the needs of the 1950s. They were built for the demands of the next century. In hindsight, these milestones of durability highlight a lesson that modern road construction often overlooks. When quality and long-term performance are prioritized, infrastructure can last far longer than anyone expects, providing safety, efficiency, and economic benefit for generations. Modern highway construction has increasingly prioritized speed and cost over durability. Pavement layers are thinner, curing times are reduced, and tolerances for materials and placement are relaxed. Contractors work under strict budget constraints, and schedules are compressed to meet political deadlines. While newer technologies offer some benefits, such as advanced asphalt mixtures or automated paving equipment, the results are often roads that fail prematurely. Cracks, rutting, and potholes appear years earlier than they would have on a 1950s highway, requiring costly repairs and creating public frustration. The contrast is dramatic. Sections of highway that would have lasted 50 or 60 years are now replaced or resurfaced within a decade. The economic cost of cutting corners, when viewed over the life of the road, is enormous. Maintenance expenses, traffic delays, and safety risks all accumulate. The lesson is clear: durability matters. Eisenhower's insistence on overbuilt highways was not wasteful, it was visionary. More than 6 decades later, the first-generation interstate highways remain a model of engineering foresight. Original sections continue to carry millions of vehicles each year with minimal deterioration. Engineers studying these roads recognize that the combination of thick concrete, steel reinforcement, careful subgrade preparation, and long curing times created highways built not for convenience, but for longevity. The system stands as a testament to what is possible when vision, discipline, and technical rigor converge. In a world where infrastructure is increasingly judged by cost and speed, the lessons of the 1950s interstates are striking. Build for durability, demand precision, and over-engineer when stakes are high, and the resulting structures will endure. Eisenhower's highways were more than a transportation network. They were a statement that American engineering could create infrastructure capable of lasting generations. Modern roads, when compared, reveal the wisdom of that approach, reminding us that quality and foresight are investments whose returns are measured not in years, but in decades and beyond.